And good afternoon. I'm always happy to be back at a Layer 1, 2, 3 event. I think I've been to about 13 of them. Last year I wore my name badges from all of them my first morning and took it off very quickly. So I want to talk a little bit about automation in the sense of network services. There's a lot of applications of the term automation, and this is sort of our interpretation of it. And MEF 3.0 is a new framework for this that we launched late last fall, and I'll tell you about it. So I'll give you my views on why automation is important and what motivates it. Then I'll describe MEF 3.0, which is not a term you can figure out by its name what it is, and LSO, the Lifecycle Services Orchestration Component. And then I'll show how we could apply MEF 3.0 to services automation. And you know, MEF is very involved in service orchestration and service enablement and agility. For the telecom industry, we're a nonprofit organization that is 200 plus members with 100 plus telecom service providers from all over the world. So what we're seeing and what you are seeing and what we are experiencing is this digital economy and the business transformation. And we see this in the telecom carriers, in their enterprise customers, and in MEF itself. So we see all this new technology that's coming along. We have new competitors. Everyone does. And new types of customers. And this is typically good for a service provider if they can manage to serve them well. And the business models and processes for greater efficiency in business, but not without some pain of change. Now, if you look at the telecom opportunity space, there's lots of new opportunities available, but they're not always easy to address. And so some of them are viewed as terrific opportunities in the telecom world and some as threats. So you see every new application and new subscriber customer wants a very much more tailored service, and they want to pay as they go. If I need a bandwidth or I need some kind of a network function, I want to pay for it only while I'm using it. I don't want to have to arrange it for 3 months and then pay for it for a year and only use it periodically or episodically. And with the advent of new machine-to-machine IoT and all these other kinds of applications, these are great opportunities, but also very challenges for how you do such a distributed service and how you, in particular, secure it, especially when things like our health and our traffic are more exposed to external network influences. And finally, we're seeing different kinds of traffic from typical voice video data with a much greater variety of requirements in terms of bandwidth, in terms of latency, in terms of distribution, and in terms of not just sort of like broadcast distribution or one-to-one, but in two-way distribution. That's why I am seeing more and more, and I often go to a hotel and I test using speed test what my link is. How asymmetric are my upload and download speeds? And they're getting less and less asymmetric. Now, this sounds great. How do we get there from here? And in the telecom world, there are a number of obstacles that I'm sure you've all been familiar with. Either you've experienced them or you offer them. Closed and bundled solutions in the product space, we hear about this, and I know the industry is trying to change this, and there are a lot of good forces toward that end. Infrastructure per service. We had the voice, video, and data. But even an example this morning in Ichiro Fukuda-san's talk about thinking about zero touch in a much broader framework, and he's talking about in the supply chain part of it, and want a service, you have to go and deliver some kind of equipment. Well, why do you need specific equipment for specific services? That does not make you flexible enough to offer services on an infrastructure you've finally invested in and gotten working. With the variety of applications and needs that are coming along, we need an infrastructure that is not unique to the service that it carries. And finally, we hear a lot about SDN and NFV, and I like to put them into one word. And once, I guess it was a couple years ago here, I gave a presentation with the shortest title I've ever given. It was SDNFV. That was the title of my talk. But how do you get there from here, especially given the challenges with current technology, legacy vendors, legacy processes and skills, and of course accessing the cloud, and then programmability of the network in general. And those are the technical obstacles, but we also have the organizational obstacles, and most of those are human. And that's where I refer to Do we have the right mix of skills? How do we change those? How do we get people to do the same things different ways or to do new things? And even as Ichiro-san implied, the supply chain is changing as well. And then, of course, processes and culture are always the slowest things to change. So these are the obstacles that face the telecom industry. Now, why do you want automation? You need automation basically to respond automatically to changes that people cannot make fast enough themselves. We use pictures of somebody at a keyboard or a finger somewhere, and I might have one of those. That doesn't mean it's a person there anymore. You know, machine to machine isn't only about robots in a factory. It's about automating workloads and responding to changes in service requirements and delivery. So what is going to change faster than we can react? Well, network state changes, traffic engineering conditions change, the customer demands change, or the business objectives can change. I mean, this could be, I need something at a particular time, or at this time, I need to offer a service with the highest security, or this is the time I really want to just maximize my profits. You know, what we get in this feedback loop is the ability to really convolve network state with business objectives. And finally, the security threats and the security tools. These are changing quite dynamically also. So if you want to change fast enough to respond to these in a proactive manner, you can't do it with people. So what do you need? You need, as actually we heard about in Bin's talk, telemetry and analytics. And a number of people have talked about this today. Brian Laris had a good explanation of what that involves. You need closed-loop control with SDN to effect the control and the remote control plane software to determine what does need to change. And then finally, this automated connection between the two, between what is the state, what should be the state, and how do you decide what the state should be based on the ongoing conditions. So this is really, I think, in my understanding of the telecom world, how to interpret automation. So what is MEF 3.0? Well, it's a follow-on to Carrier Ethernet 1.0, which was a service specified, and Carrier Ethernet 2.2, which is evolution of that service. Well, MEF 3.0 is an evolution of that, but it's like apples and carburetors. So it is a much larger concept than Carrier Ethernet, but Carrier Ethernet will be the first instantiation of it. So it's this whole reference framework for defining, delivering, and certifying services that we believe need to be agile, assured, and orchestrated. And this is why we're so interested in orchestration. And not just in a single operator's domain, not just in a single technology domain or transport domain, but over multiples of those across multiple operator domains. And really, MEF is making faster strides than anyone else I know in the operator-to-operator area. So we have these 4 pillars, and I'll describe them in more detail on the next slide, but really what we want to do is communicate subscriber intent, and we show the finger there, but this is an application intent. We're doing this application intent work in MEF, conveyed to the business applications and then the service orchestrations and the actual resources through these sort of abstract pictures that I've drawn here, not just with a single operator, but with multiple operators. So you want to order things, you want to control things, and you want to effect the services that you've got, and then keep them up to date. So this notion of intent is important for everything we do. And it really shows that our thinking has evolved considerably from layer 2, Ethernet, much higher up in the stack. So this is the framework of the 4 pillars of services, LSO APIs, community, and certification. And the services are, as I said, agile, orchestrated, and assured. So we want them to be orchestrated and dynamic, but it's a variety of services, not just layer 2, but layer 1, as I've shown, in both optical and 5G, wireless services, layer 3, and then layer 4 to 7 types of services, such as security as a service, SD-WAN as an overlay on an infrastructure, and other application services. So we are concerned about more than just layer 2 transport service, but we are still concerned about layer 2 transport service. So lifecycle service orchestration has these APIs, and I'll go into a little more detail about those, but these are open APIs. They are becoming adopted across the industry. In the the talk that we had earlier by Pronap, they're actually starting to do that, and we're going to help them make that a little faster. So this is over multiple technologies and transports and multiple service providers. But they include, as I'll describe more, both the specifications or the standards for these APIs and actual running code to describe them in software development kits. In community, it's no longer anyone staying in their own silo, least of all us. So we work with many other software development organizations and with the open source projects. We've actually contributed code to these projects, and we use them to instantiate our concepts and validate them, in fact. So we want to help accelerate their deployment. My lunchtime debating table yesterday was on getting open source into deployment. There's a lot to do to get it into deployment. As you know, no operator is going to go to GitHub, they hear about a great project, go to GitHub, press install and run their network. Many steps in between. We want to help with those. And then we've expanded our own mode of operation and sphere of community to include an enterprise advisory council from major enterprises you've heard of. They're not members. We just get together informally and hear their requirements, use them to steer our work program. We have something called MEFnet, which is an experimental sandbox, really, to try out all these ideas with tremendous computing power and lots of VMs and containers. And you can go and exercise these things and try them out before we finalize them, or you actually figure out how to implement them yourself in production. We're doing hackathons. We have a developer community out of the research community around the world. And then we have our new program just launched a couple of weeks ago, or announced, for certified professionals beyond carrier Ethernet skills. We have network foundations and SDN and NFV and up from there. And Rick Bauer here in the front row runs the whole certification program for MEF. And then finally, in the area of certification, you don't carry a box to San Francisco anymore and get it certified for this service and your services also. It's a much more agile process itself, and it's online, it's in the cloud, it's from where you are. And it's terrifically more flexible. And the head of that is Bob Mandeville here in the fifth row. He runs that part of this process. And if you're going to offer international services across carrier boundaries in anything that's going to be certified as MEF 3.0, you're going to want to have a certification that tells some operator in another country, hey, connect to me, I can do this with you, you can do it your way, I'll do it my way, but it'll work end-to-end for a global customer. So this is the Lifecycle Service Orchestration Reference Architecture, and it's got three elements here. The customer on the left, their local operator in the center, and a partner on the right as another operator. And the customer wants to establish some kind of a service to some kind of another location. Their local operator does not actually cover that. So they go to a partner as a wholesale provider to reach that. How do they communicate this in an agile way, not taking 3 months to set it up? And these are the interfaces and the abstract notions we have of the business applications and service orchestration functionality and so on. And then we've defined these interfaces. We call them APIs, but some are east-west. So Cantata and Sonata are east-west for service initiation, and then Allegro and Interlude for service management. And then the vertical ones allow you to operate any of these functions independently of how the ones below it are actually implemented. So the service orchestration functionality over Presto to the SDN controller, for example, without really caring how it does, and so on down. So we are gradually issuing these in greater and greater detail. So if you take this and apply it to what a network sort of looks like, you actually use these interfaces to instantiate and run services over a variety of infrastructure choices that are really left to the operator, with no religion on our part about what orchestration system you use, open source or proprietary, and what kind of SDN you might use, or even just physical network functions and not VNFs, and so on. So tremendous flexibility in the choice of how the operator takes short-term steps to get to the ultimate destination. So we have these formal things we do. We define APIs formally and services. We have information models, and from them we derive data models in an automated way. The formal interface profile specifications, these are our standards. And then we certify things, but we have informal things we do now we did never used to do before. We run the hackathons, developers. We issue the SDKs before the interface profile specifications. And we're on a DevOps kind of sprint cycle here to do these. So it's almost a DevOps form of standards evolution. And I mentioned these other things, and some reference and example implementations, and we had a couple of those last fall that kind of shook up the world. So information modeling is extremely important as a foundation for doing this the right way and doing it once. And this involves the choice of language and the patterns and these things I mentioned here, and especially the tooling. And this is just kind of a flowchart of the integrated development environment that we are fostering and using and working with partners in the same manner. I list down the bottom a number of organizations that we actually work with quite closely because we did host a meeting. It was an ONAP meeting that we hosted in Los Angeles last month to kind of hammer out common approaches to the modeling and the tooling for this so that we could agree on a common approach or a federated approach that allows us to derive the data models and the running code and then interact with each other. A really, really important effort. Just being model-driven really leads to the automation, and you've seen this in a number of scenarios. I'm showing them here just in general. But if you start with the right models, you can have execution engines themselves are automated, and the behaviors can then be automatically created and changed. So we have an analytics and assurance project for this feedback loop, working with Panda from the Linux Foundation. I won't go into detail here, but it's part of this closed loop that's important. And when you abstract all these management functions, then you can automate them, and we have ways of communicating between them, but it gives you a much more, I would say, computer science approach to operating a network than ever before. So my final slide here is, how do you derive automation from MEF 3.0? And I see these as being the ingredients here. We have the service definitions which allow you to standardize the behavior expectations. The network abstractions on that LSO chart to disaggregate the monolithic operational support system, the BSS, the network management and element management systems, so you can abstract them, implement them however you wish, and talk to other abstractions over a common way without knowing their details. And that's what the APIs do. They isolate these functions and the applications, and they allow you to interconnect operators. Being model-based gives you cloud-native automation and the information models and tools to auto-generate data models and then the running code. The customer portal will be automated over time, and it's starting to happen now to auto-feed real-time requirements once the customers know what they are in real time. That's been a challenge up to now. And then the analytics for this loop and what we're getting from Panda is the gathering of analytics, not just through polling, thank God, but also through streaming and batch if you need it. And the services to create and orchestrate and manage them really by a machine. So we think you can gain service agility and revenue and automation through MEF 3.0. Our goal is always to create business opportunities and improve business for not just our members, but everyone in the telecom industry. So we're focused on business success. Thank you very much.